Okay, so in this video, we're going to talk about a new topic called lists. We're also going to review a little bit about strings. In your next app, you're going to be working with both of those things, lists and strings. And so I just want to make sure that strings are fresh in your head. And then you also have the information that you need about lists. Just one word of comment, because this is the first time this school year that we're doing notes through a video. I just want to make sure that you're clear with the idea that I'm going to present the information that's on the particular slide. I'll talk about that. But when I'm done talking about the information on that slide, I am going to move on to the next slide. It might be important for you to make sure that you can hit the pause button quickly. So if there's something that I say and then move on before you can capture it in your notes, hit the pause button so that you can write that down. Or if I say something that's not on the screen that you think is important to have in your notes, pause it so you can get the stuff from the screen copied down and then add in the stuff that I've said out loud. Okay, so just remember that you've got that pause button. Use it judiciously as you watch this video. All right, so let's get started by taking a look at our slides here for today. So what we have are notes over lists and strings. This is what we're talking about for today. And our learning objectives, like I said, we're going to review strings just a little bit here. So that's the first thing we're going to do is just review strings. But then we're also going to talk about what a list and what an index is. And we're going to talk about how to use lists and indices to store and retrieve data. All right, so that's the main idea for this set of notes. Let's get started with some review. Some old definitions. The first one being variable. Okay, at this point in our class, we've worked with variables quite a lot. You should be very comfortable at this point with what a variable is. So if you need to pause the video for just a second to think about that. But what is a variable? So hopefully you came up with something along the lines of a variable is a place where we store data. And in our class, we've been using this analogy that variables are like file cabinets, right? It's a place where you can take a piece of information, go and put it into that variable, and then later when you need it, you can take it out of that variable, just the same way that you would take a piece of paper and put it in a file cabinet, and then later you could take that piece of paper out of the file cabinet. Right. One thing that will be true with both lists and variables, like it has been with almost everything we've done, remember that your computer is a very stupid, very literal device. So it's only going to do exactly what you tell it to do. Just like it won't store a variable unless you tell it to set the variable to be something, the same is going to be true with lists. Okay, but I'm getting a little ahead of myself. Let's get back to our review and talk about strings. So what is a string? Now, strings are something that we have talked about and we've used them a little bit in our class, but we haven't used them to the extent that we will in this app. So it's important that you've got strings fresh in your mind. So it might be beneficial for you to pause the video and flip back in your notebook to see what notes you already have about strings. And if there's something that I talk about over the next couple slides that's not already in your notebook, then you'll want to make sure that you add this in. But a string is a particular kind of variable. And specifically, it's a variable that holds within it letters and numbers and symbols in a particular arrangement, okay? That's different than a numerical variable like a float or like an integer where it only holds numbers and you can't put in letters or symbols, okay? It's also different than a Boolean, which just holds true and false values. All right. Now, one thing that's important to make sure you realize is that the way a string holds numbers is different than the way a float or an integer holds numbers. Okay. In other words, in a string, it sees the number sitting there and it thinks it's just a symbol like anything else. So for you to take a string that has a 2 in it and add it to another string that has a 5 in it, the computer isn't going to recognize that as 2 plus 5 and give you 7. It would, in the computer's mind, it would be the same thing as doing like an A plus a Z. That doesn't make sense. You can't really add symbols together like that. So that's one thing to make sure you realize is that it's important that if you're going to use numbers as numbers, that you use an integer or a float variable. And if you're going to use numbers as a symbol or as part of a name or part of a password or something like that, then you're going to incorporate the number into a string. Okay, so that's just a side comment. All right, Now, some other things to make sure that you are good with. I mentioned a second ago passwords. Strings are a lot like passwords. So in the app that you're getting ready to build, you will need to be able to find certain strings within a list. You'll also need to be able to check to see if strings are equal to each other or not. And so when we talk about strings, you want to think of this just like you're used to with passwords. So for example, the order of the characters is very important. If you switch the orders, then you have a different string, just like it would be with a password. Uppercase letters and lowercase letters are different. So if you have a string that starts with a capital A and a different string that starts with a lowercase a, the computer will see those as two different strings, all right? And then just like passwords, this hopefully makes sense, but I'm going to show you an example of some place in a minute where this might not be obvious, but symbols and spaces matter. So if you have a space in the middle of your word, that's different than if the space is not there. Now, where this really becomes important is autocorrect, right? Or autocomplete. If I'm typing on my phone and autocomplete pops up and it suggests a word and it pastes that word in, if it puts a space at the end of the word, that could be a huge problem for me, because in a string, that space matters. And so if I'm not aware of the fact that autocorrect or autocomplete has put the space into that word, I'm going to have issues. I'm going to need to watch for that. Okay. Now, when we talk about strings, the way that we know a string starts and stops is by using quotation marks. Now, I will say in App Inventor, it's really easy because you get a block that has quotation marks built into it. In other computer languages, this is something that you're just going to type in. And so when you see that quotation mark, you know that's starting a string. And when you see another quotation mark, you know that ends a string. Okay. Now, as a side note, in some computer languages, instead of quotation marks, they use apostrophes. So instead of having two, there's only one. So just so you're aware of that, not a huge deal. Okay, here are some examples of things that we have done with strings already. So these are blocks that we have worked with. When I take a string variable and I put in this empty quotation block, that just deletes whatever was in the string in the variable before. So it's like having an empty folder in my file cabinet or having an empty file cabinet. Okay. We've used the join block that hooks two strings together. Now the trim block, I'm not sure if we've used that very much, but what the trim block does is it cuts spaces off from the beginning and the end of the variable of the string. Okay, so like I was saying before, if you have somebody who uses an autocomplete feature and that autocomplete automatically puts a space at the end of their word, if you don't want that space to be there, then you can just add a trim block into your program and it'll make that space go away. All right. And then another thing in this we have worked with, we have seen, is you can switch all the letters in your string to be capitals or lowercase letters by adding this block. And remember, these two things are the same block. They just have you just hit the arrow to choose between uppercase and lowercase. All right. So, excuse me. So that is a quick review of what we've learned about with strings before. And in this particular app, you're going to use all of that information and maybe even more. All right. But you're also going to use lists. So let's move into talking about lists. Okay. So first of all, what is a list? Well, in computer science, a list is kind of, and remember, this isn't a hard, fast definition. This is just a definition that's designed to give you a basic idea. All right, so some textbooks or some computer scientists might define this differently, but to tie it into what we've learned so far in our class, I'm going to define a list as being a special kind of variable that's able to store multiple pieces of data. Okay, so when we talk about variables, we know from all the variables that we've worked with before that you can only put one piece of data in there at a time. Now, depending on the variable, that changes what kind of data you can put in there. Booleans only hold true and false, but it's either true or it's false. You can never have true and false both inside of the Boolean at the same time. It's either one or it's the other, right? Same thing with integer variables. Either it's a 1 or it's a 2 or it's a 3, but you can't have a 1 and a 2 and a 3 all at the same time. It's got to be one or the other. Lists aren't like that. Lists are able to hold multiple pieces of data. So I could have a 1 and a 2 and a 3 and a true and a false. So I could put all of that data into my list and it would be just fine, right? So we said variables are like file cabinets. Let's extend that analogy a little bit further and talk about how variables and lists are similar and different. So if a variable is like a file cabinet, it's a very, very boring file cabinet because it can only hold one piece of data. So it's like a file cabinet that only has one drawer, and inside of that drawer, there's only one folder. There's only one place to put information, and it's a really small folder. I can only put one piece of paper at a time in it, and that's it. That's all I can put in my variable. But a list, on the other hand, a list is like a file cabinet that has lots of folders inside of it. So every folder can hold its own piece of data. And the number of folders that I put into it is really just based on the limitations of the memory of the device that I'm working with. So in theory, I could have a list that's really, really long, okay? So that's the difference between a variable and a folder. Of course, or I'm sorry, a variable and a list. But of course, the trick becomes if you have lots and lots of folders in your file cabinet, how do you know which folder contains which piece of information? And then how do you find that folder when you need it? That becomes the trick. And that's really what we're going to talk about in the rest of our notes here. So this brings us to our next and our last vocabulary word, index. So the problem is keeping track of all the folders inside of this file cabinet or all the little slots inside of your list. Well, each one of those folders or each one of those slots gets a number, and we call that an index. All right. So for our class, we're going to use the index to refer to the number and to refer the slot both. Okay. So we're going to use that word two different ways. So in the folder analogy, in the file cabinet analogy, the file cabinet is my list. Each folder is an index, and each one of those folders has a number on it. And so we would say the very first folder is index number 1. And then the second folder is index number 2. And the third folder is index number 3, and so on and so forth and such and such. Okay. Now, another little word of caution that's going to come up later in the school year when we move from App Inventor to other programming languages. App Inventor is really nice when you're first learning lists because the first folder, the first slot, the first index is number 1, and the second one is number 2, and so on and so forth. But in a lot of programming languages, they number it differently. And we're going to see that when we study App Inventor, or I'm sorry, when we study VEX and when we study Python, they number their indices slightly differently. And there's a reason why they do it the way they do it. But just be ready when we get there, we're going to have to make a little tweak. Okay. But for now, it's very intuitive. Slot number 1 is index number 1. Slot number 2 is index number 2, and so on and so forth. Okay. Now, the last thing that we want to say about an index is that each index gets added as it's needed. So if I have a list that has 5 things in it, there's only going to be 5 indices. All right. So if I take that list with 5 things in it and I tell the computer, look at index number 6, or I say, go to the file cabinet and look at folder number 6. If the computer only finds 5 indices, that's going to cause an error. The computer's not going to know what to do. It's going to get confused. It's going to be like, hey, I trusted you and you said look in folder number 6, but folder 6 isn't there. And so I'm not sure what to do. Have I made a mistake? Should I not trust you? Is the list broken? What's going on? So one thing you're going to have to do as you're writing your program is you're going to have to be very careful to make sure you don't accidentally create a situation where the computer is looking for a folder that doesn't exist yet. All right. Okay. So this is just expanding on that same idea. All right. So let's take a look at a few different examples of lists. Okay, so here I've initialized a list. These are blocks that you might pull out in App Inventor. So here, notice the initializing a list looks an awful lot like the initializing a variable. And that's why I'm defining a list as just being a special kind of a variable. So here I've initialized my list. I've called this list 0 is what I've called it. And I've pulled out a block that says create an empty list. So what that means is that this list, when the program starts, when this variable, when this list gets initiated, there's nothing in it. And because there's nothing in it, that means literally there is nothing in it. There's no data, there's no folders, there's no indices, there's nothing. So if I tell my computer, go look into that list 0, no matter what index I tell it to look at, it's going to generate an error. So before I can have the computer look in the list, I have to put something in that. Now, because of that, it's generally considered good programming practices to never initialize your list as being empty. Usually we always put something in the list just to make sure there's at least one index in there. So that brings us to example number 2. So here's an example of initializing a list so that there's one thing in it. This particular list, which I've named list 1, has a list inside of it that has exactly one piece of data. The data that's in it is a string, and the string contains the letters MHS, but it just simply is one piece of data in this list. So I could now tell the computer, go look at index number 1, and I wouldn't get an error. It would be able to go there, it would look, it would find the letters MHS. All right. Now, here's another example that has 3 different folders in it, or 3 different indices. All right, so you can kind of see how this works. Now, one question that students have is, how do I get these different little tabs? If I want it to be 0 or 1 or 2 or 3, remember, whenever you have a block with a gear, when you click on that gear, it gives you other options. And notice that every one of these blocks has had that gear on it. So these are actually all the exact same block. You just click this gear and it will let you add in the slots that you need to put more things into your list. All right. Now, what I'd like you to do is take a look at this particular list. All right. And what I want you to do is answer a couple questions about it. And so I'm going to put all the questions up on the screen here. And I'm going to ask you to pause the video and answer all 4 of these. So based on the blocks that you've seen here, what is the name of the list? How many indices does it have? What data is stored in index number 4? And what will happen if I ask the computer to look in index number 6? All right, so pause the video and answer those 4 questions now. All right, hopefully you've answered those questions. So the answer to the first question, the name of this list is pretty boring. It's just list, okay? And we've talked about that's actually a pretty bad programming practice, right? We want to give it an informative name that makes it easy to recognize. This particular programmer just called it list, but it is what it is. How many indices does it have? Well, each one of these slots is an index. So we've got 1, 2, 3, 4, 5 indices in this list. What's in index number 4? 1, 2, 3, 4 is a string, and that string says Tom. Okay. Notice that this list, in its different slots, it has different kinds of data. It's got strings in 3 of its indices, but here it has an integer, and here it has a Boolean. Okay, so lists can hold different kinds of data, and that's okay. In fact, if you really wanted to get crazy, you could have a list, and in one of these slots, you could put another list. And it's just like, oh my goodness, list inside a list, things get really funky, all right? But that's something that you could do, and that would be fine. Final question, what would happen if you looked at index number 6? Well, because there are only 5 indices, if you told it to look at index number 6, the computer would get confused and it would generate an error message, all right? So that's the end of our notes. What we're going to do now is we're going to switch to another video. So I'm going to stop this video now, and we're going to switch to another video. And in the next video, I'm going to show you in App Inventor how to do some things that you'll want to do with lists. So these are the things that we're going to look at in the next video. And I'm going to show you where the different blocks are and how to do these different things, so that you've got that information and you can find it when you start your next app. But for right now, that's it for this particular video. Thanks for watching this. And make sure that you tune in or watch the next video where I will take you through App Inventor and I show you where all those blocks are and how to do those different features. You're going to see in that there's actually a couple different ways to do many of these features. So, so make sure you watch that video, but that's it for this one. Thanks for watching. Have a good one.